Hello, everybody. Thank you for coming to Hack Sprint session 3. We're going to be talking about states and bindings today. So as always, here's the links to the slides and the README, and they're dropping it in chat. So, woo. And then once again, the feedback form, please fill it out so that we know how to improve, and you guys can also get prizes at the end. So I think it's in your self-interest to fill it out. And once again, join the new Hack Discord server. People put in a lot of work to get that up, and you can stay up to date with everything Hack's doing from Hack Sprint to Hack on the Hill. And then, so one more thing, UCLA is transitioning back to in-person events now, and we are thinking of doing all curriculum-based sessions, so up to session 5. So this week, next week, and the week after online. And then after that, we're going to talk and figure out whether we want to go in person or not. So we'll update you guys as the date comes closer. And project apps are due tonight. So fill them out, and you can create an app using the knowledge that you gained throughout the quarter. And then you can showcase your app during week 9's workshop. The sign up link is here. I highly recommend that you do this because A, it looks good on your resume, and B, it's so much fun. So please sign up. And we are on session 3. I mentioned earlier, we're doing states and bindings today. Woo! And we're gonna be recapping views and view modifiers, talk about more views and view modifiers, making our Tamagotchi app, talking about closures, states, and bindings. So about coding along, we encourage you guys to try out the things that we cover after the workshop, but we don't recommend coding along. And the README has all of the talking points from the workshop, so don't worry about like memorizing everything we cover. Like, you can just refer back to the README. And then you can ask us questions on our Discord. Another reason why you should join the Discord. Yeah. And ask at any point if you are confused. We are here to help. So I mentioned earlier, we're creating a Tamagotchi app, and you can see here on the right that this is what we are trying to create. And as we go through the slides, try to see what you can use to create this app. If you follow the README link, you will find a folder with the starter code for this project, so you can start there. So a recap. What's a view? La vue, as the French say. I don't actually know. I Google searched that because I don't speak French. Clearly, it's a nice scenic outlook over the city, which I mean is correct, but not exactly what I'm going for. Your view, thank you so much for being here for Hack Sprint. We're so glad that you've joined us. But really, what I'm talking about when I refer to a view is the building blocks that allow you to add content to the screen until it is in a state you desire. So for example, in this app that I unabashedly stole from Nari's session 1 workshop, the views would be the text, "I love French toast," the text "I," and then the text block, really, text "do," and then the image of French toast. Let it be known that we're going to be talking about a lot of views and view modifiers throughout the session, and you do not have to know all of them off the top of your head. I have included the Apple developer docs right here, so you can refer to them. And then let's talk about the text view. The text view displays lines of text to the screen. So here's an example of the syntax. We've got you declare the text view with the word text, and then you have parentheses, and then anything within the parentheses and within quotation marks will be printed to the screen. So in this case, hi, my name is Shirakuma, and I really like hot tea, and I like hot tea, it would be printed to the screen. For those of you who don't know, Shirokuma is a Sumiko Gurashi character, and he's the shy little polar bear we see here on the right, who migrated south to avoid the cold and feels most calm while drinking hot corn and tea. So essentially, Shirokuma is my spirit animal. Okay, image views. Image views place an image from the assets folder that is already included in your Hex Code project onto the screen. So you don't have to worry about like creating an assets folder. It's already going to be there. And this is how you put an image on screen. You declare the image view with the word image, and then you have parentheses, and then anything in those parentheses and quotation marks, as long as you have an image in your assets folder that's named like what you have in there, it'll show up. So in this case, if I have an image named Shirokuma and Tea in my assets folder, it'll show up on screen, and you can see Shirokuma and Tea right here on the right. Okay, one last bit of a review. Let's talk about stacks. Why? So we can organize things. Who doesn't love organization? Let's start with V-stacks. V-stacks are vertical stacks, and they allow you to align views vertically down the screen. So here we see an example of the syntax. We declare the V-stack struct. If you don't know what struct is, I think we covered it last session. If you have questions about it, ask during break, because it's not within the scope of this session. We declare the V-stack struct, we have curly braces, and then we list the views inside the V-stack. And what this does is it puts view 1 on the screen, and then it'll put subsequent views below it on the screen. So we end up kind of like, with Furoshiki, like with this image on screen, we have like Furoshiki, our luggage, on top of Shirokuma on the bottom, with Furoshiki representing view 1 and Shirokuma representing view 2. H-stacks are another type of stack, and they allow you to align views horizontally across the screen. So we have the syntax here. We have the H-stack struct, and then not parentheses, curly braces. And then every single view you have inside the H-stack will be aligned from left to right on the screen. So let's say, for example, we have this image here. We would have view 1. View 1 would be Shirokuma, and then subsequent views would be on the right of that. So view 2 would be our brown crispy friend here, Tonkatsu. View 3 would be Penguin, and view 4 would be Neko. Oh, one more thing. You can also mash stacks together. So like you can nest them inside each other as you would like to arrange views on the screen. So let's talk about some new views. And we'll start with Z-stack. And you thought you were done with stacks. No, we've got one more. Z-stacks allow you to stack views on top of each other in a pile. So it's basically like stacking up in the Z direction. So you can imagine the Z direction to be coming out of the screen towards you. So I think it's best to illustrate it with an example. And we have the Z stack here, and the image on right actually represents a Z stack really well, because the first view you list, Tonkatsu, would be in the back, and then subsequent images would be layered on in front of the previous images. So then our next view is Shirokuma, and Shirokuma is layered on top of Tonkatsu, and Neko is layered on top of Shirokuma, and Penguin is layered on top of Neko. Does that make sense? Do you have any questions? Because it's a little nuanced. I'm going to take that as agreement. It's a prolonged silence. So we're going to move on. So we know how to align our views now, but they're kind of oddly scrunched up on screen. So how do we like give them space to breathe, you know? Spacers. The answer is spacers. You can, in a stack, an H stack or a V stack, you can use a spacer to, guess what, space things out. A spacer takes as much space as possible on the screen. So I'm going to illustrate this with this code on the left. So here we have a V stack, and we have a V1, a spacer, view 2, and view 3. And the best way I thought to explain this would be this image right here on the left. Without the spacer, our fluffy little puff ball here, Hokori, would be right on top of Shirokuma's head. But because of the spacer, Hokori is pushed all the way to the top of the screen, and Tokage and Shirokuma are pushed all the way to the bottom. See, we have the spacer taking up as much space as possible. But that's not really helpful. Like, why would you want a whole bunch of empty space in the middle of your screen and like all of your little like views on the top and bottom? Well, spacers also work well together. So that means no more empty spaces in the middle. Here we have an H stack to show how spacers can be used to work together. We have view 1, spacer, and then view 2, spacer, view 3. And the result is kind of like the image we see here on the right. View 1 is represented by Zasu, our little weed grass friend. And then the spacers around view 2, which is represented by Ebifurai no Shippo, in the middle here. The spacers force Ebifurai no Shippo into the middle of the screen. And Zasu is pushed all the way to the left. And then view 3, our yellow tapioca friend here is pushed all the way to the right. So we end up with 3 equally distanced views on the screen. You can actually arrange spacers as you see fit in your app. So you can organize your views any way you like. Okay, one last view to cover today, buttons. Buttons are very self-explanatory. They're views that the user can click on to cause an action. We'll talk about actions later today. But for now, here's the syntax to create a button. You declare the button, and then you have parentheses, and you've got some very odd syntax here. Don't worry. You can once again refer back to the Apple developer docs to remember it, or you can like search it up like in the library in Hex Code. You don't have to memorize this. Please don't feel like you need to. So we declare action, colon, we have curly braces, and then within the curly braces is the code that's going to run when the button is pressed. And then outside of the parentheses, we have yet another set of curly braces, and inside of those curly braces is going to be the view that we're going to make a button out of. In this case, the text drink tea is going to be the view that we're going to make a button out of. The text itself, drink tea, will be the button. Okay, so do we have any questions before we start the first part of the demo? Okay. We're going to start with the demo. Once again, you guys have the starter code in the GitHub repo, which you can get to by following the README. So I have created this Hex Code project already. And let's talk about the assets folder. I mentioned that a little earlier. As you can see here, I have a bunch of assets already, and you don't have to worry about importing these because we've already got them in the starter code that you guys will get. But what I do want to point out is like, here are the images that I imported, like that I can refer back to when I call an image view. And here is a color set. We didn't actually talk about color sets, but I'll go over them briefly. Color sets are basically names that you can give to colors that you want to save, like colors that you're going to reuse multiple times in your project. Now, the reason why you want to do this is because if you don't, in your code, you're going to have to keep writing out the same hex code, like over and over and over again, and that gets really tiring. What's a hex code, you ask? Well, I'm about to show you. A hex code is a 6-digit hexadecimal number that represents every single color out there. So you can play around with the color wheel in Xcode. You just create a new color set, and then you click on the color itself, and you come down here to show color panel, and you get a color wheel. And whenever you click a new color, you can see that the hex code changes. Oh geez, what the heck? Yeah, so you have a hex code to represent every single color out there. I've already chosen a color. It's DAFFFF. And we're going to use this for the background. We're going to use this color for like accents and button colors. And then this is the text color. You guys can change it in your own app if you want. But let's start with putting all of our views into our app. We're going to ignore this restart button up here. That's going to be an exercise for you guys. So have fun with that. One last thing, I'm going to be typing out all of the views and view modifiers. I think it's the first time we're doing this in a demo for this workshop. So you don't have to worry about memorizing it. I already have inside knowledge, which allows me to build this app by typing it up. You can always do like the library function once again, which is the plus sign up here, and then you can just search it up. So what is the first thing that we need for this app? I'd say we need a VStack to put all of these items in there. So I'm just going to do that. So VStack. And then we saw that we needed the text. Keep the Tamagotchi alive. And then if you notice over here, keep the Tamagotchi alive is in all uppercase letters. And clearly I did not type it in all uppercase, but there's actually this instance method called dot uppercase for strings, and you can use it on any string. So, excuse me. Okay, I just like changed the YouTube. I just changed the device that we're like building stuff on to be an iPhone 13. Don't worry much about that. And then we need, to put the image of the Tamagotchi in, and the score, the health, this progress view bar, and then a button. Once again, I have insider knowledge. I've built this app before, so I'm going to put another VStack here, mainly because I already know that it's going to be useful for spacing things out and just like styling things. And then I'm going to put in the image. I named the image of the Tamagotchi Happy.
Could you put the slide picture like somehow positioned next to the code so we can like refer back and forth?
Let's see. Okay.
I think the preview should be good enough if you get that up and running.
What preview? Oh, Jesus Christ.
You can swipe up and then like drag it into the desktop, I think.
Yes. Oh my God. It's loading very slowly. I'm sorry, guys.
I think I know what you mean by doing a nested VStack, but I wanted to see.
Oh, nope, that's not what I meant to do. Uh-oh. Okay. There we go. Okay, I'm gonna shove this out there. Is that good enough? Can you like see it?
Yeah, that looks great.
Okay, cool, good. Thank you for letting me know. Okay, so we have the image in there, and then next we want the score and the health, right? Once again, I'm gonna put in a VStack because I have previously done this, and I know that we want to align score and health by the leading edge. See, because the rest of the items in the VStack are aligned by the center, and we want these to be aligned differently. So we're going to put them in another VStack. So text, score. For now, the score is going to change because in the end, we're hoping to get an app where the progress bar is constantly like decreasing, and you have to feed the Tamagotchi in order to keep it alive, and your score and your health will change. But for now, we're going to hard code it because that's easier. And then we're going to do text, health, another 100 because I like getting 100, and I'm hoping I can manifest 100 on my midterms. And then outside of the VStack, because we're no longer worried about leading edge alignment, we're going to do progress view. And it's going to have a value. Okay, progress views have a value between 0 and 1, and they get really angry at you if you go anywhere between 0 and 1. And so we're just going to put 0.5 because that's nice. Oh wait, I wrote that wrong. We're gonna do 0.5 because that's like halfway there. And you can see the progress view has shown up right there. And then one more thing, we need a button. We have the weird syntax, weird ugly syntax. We're gonna not worry about the action for now. And then we're gonna put in the text, feed. And then we're going to do once again dot uppercase. Okay, so we have successfully gotten all of the views we wanted in, right? Cool. Let's go back to the slides because now we know how to make things pretty. And now we know how to make things show up, and we know how to align our newly spawned views. And we know how to space them out all fancy, but how do we make them look pretty? The answer, friends, is view modifiers. Woo! Okay, view modifiers are the extra sprinkles and confetti that make things look pretty. Okay, previously in previous sessions, we've said that view modifiers tend to follow the format view and then dot modifier and parentheses. Each modifier will style the view in a different way. So first, let's cover Textview Modifiers. We went over these 4 in session 1, I believe. Bolds the text. Italicizes the text. I mean, like, who would have guessed? And then foreground color colors the text. Background colors the background of the text. Some new text modifiers that we'll be using today are tracking, which adds spacing between characters. An example is tracking 2, and that will introduce a spacing of 2 pixels between each character. Font changes the font size. So if you did font headline, then that would change the font to the headline font size. There are other font sizes that you can use, and once again, those will be in the Apple developer docs, so check those out. Line spacing changes the line height, so line spacing 22 will change the line height to like 22 pixels. Image view modifiers, we also went over this in session 1. Resizable declares that an image should be resizable, otherwise images just won't do it. Because they're stubborn like that. Scale to fit, resizable works really well with scale to fit and scale to fill. which are our next two view modifiers that we're going to cover. Scale to fit resizes an image to fit the screen width, and scale to fill resizes an image to fit the screen height. And then frame changes the image's width and height. Okay, some new image view modifiers. We have corner radius, which rounds the corners of the image. The larger the number you put in, the more round the view will be. And then we have shadow, which creates a drop shadow of your preferred color and like width. And then the X and Y you see here are the offsets from are the X and Y offsets for the shadow with relation to the view itself. And then border outlines the image in the border color of your choice and with the line width of your choice. Okay, one more thing for images, you can also use the dot overlay modifier. Overlay layers another view on top of the view you currently have, and you can overlay shapes onto your view. So like ellipses, circles, rectangles, capsules, rounded rectangles, yeah. Here on the right, you can see an example of code. So we have the image, Shirokuma NT, and we overlay it with a circle, and that's how you get our square image to become a circle. And then, of course, there are some modifiers for shapes, as for our overlaid shapes as well. We have fill, which fills the shape with the color of your choice. And then we have stroke and stroke border, which there's a small nuance between them. I'm not going to cover them right now. If you're really curious, you can ask during break or like afterwards. But they basically just add a border of your chosen color and line width to the shape. Okay, button view modifiers. These are super fun. So for buttons, you can basically reuse text and image view modifiers. And I think the best way to illustrate it is by walking through this piece of code that I have here. So we see once again that we created a button, we have the action, we're not worried about the action right now. And then we have the text string T. And then to modify the text, we turned it to the headline font size. We've made it white, the text white, and then we've added a 3-pixel spacing between all of our characters. And then once again, with the button syntax being kind of odd, all of the view modifiers I just talked about only modify the text itself. If you want to modify the button, you have to go outside of the curly braces, like outside of the last curly brace, and then you add your view modifiers there. So here we see padding, which changes the border of the view to be beyond just the text itself, like beyond just the limits of the text. And then we've changed the background color to black, and then we've added a corner radius of 15. And here you can see the result of all of that code in this tiny little button. Yeah, it's a lot. Penguin agrees. But it's worth it. You've made a pretty cool button now. Okay, last thing about views and view modifiers. The entire device screen is actually included in a view. It's called the background view. And when attempting to lay an image or a color across to cover the entire screen as like a background, you might notice some white spaces at the top and bottom of the screen with certain devices. For example, the iPhone 13, which is the device that we're actually building our app on for Hex Code. The reason why these areas are white is because there might be some important information there that the app doesn't want to cover. For example, the time and the battery level and maybe the home bar. So if you've committed and you decide you really want to cover the safe area with your chosen background, then here's the view modifier for you. Dot ignores safe area. And so here I have an example piece of code. This will color the background color dot blue will color the background blue. And without .ignore safe area, we actually get this image here, this left iPhone image. We have the ugly white spaces at the top and bottom. But once you include .ignore safe area, you get this image on the right, and you can see that it completely covers the screen with blue. And here we have Penguin determinedly trekking into the safe area to cover it with blue for you. Okay, so now a poll is going to come out. Have I lost you yet, basically? Okay, it seems like we're mostly good. But only like 68% of you have participated. That's pretty good. It's above a 50%. Okay, we're gonna end this poll. And then there's a second poll, and it's gonna ask you what you guys want me to recap real fast. Okay, polls closing in 5, 4, 3, 2, 1.5, 1.25. Okay, 0. We're ending this poll. So it looks like some of you guys want to recap views, view modifiers, stacks. Okay, at least everyone got the safe area. What do you guys want to recap in views, specifically in view modifiers and stacks? Just like drop it in the chat. And like if you're confused about like something specific. You can also take it offline on like Discord if you want, because like because I got to do the second part of the demo. So 5, 4.
I have a question. Like,
Okay.
Not like about the content, but maybe it's supposed to be like that, but the file that I opened up like has nothing, or like it has hello world and that's it. I suppose it has all your like assets, so that's cool.
It has all the assets. Okay.
Yeah, I thought it'd be like the final app, so we could like follow along with the code, but this is fine.
There is a version with the final code on there. It's not the starter app. It's called like demo code or something like.
I see.
Yeah, there's a different file with the final code in it if you want to look at it. Yeah. Yeah, Eugene just put it in the chat. So okay. Okie dokie. I'm going to assume that you guys have taken it offline to Discord, or you've asked someone, or you're going to drop it in the chat at some point. And I'm going to move on to demo part the second. We're going to enter the view modifiers. We're going to do some background coloring. We're going to add in spacers, and ugliness is going to exit stage left, pursued by bear. Okay. Let's close this. And then, okay. So I'd say the easiest part of this would be adding the background first. So we're going to actually use a Z stack to layer the to layer our original VStack on top of a blue background. So I'm going to do ZStack. I'm going to seize everything in this VStack, and I'm going to just plop it in to the ZStack, and then I'm going to do color. And here's where the asset, like the color sets, actually come in handy, because imagine having to remember the hex code. I could not. So I'm just going to call background color, which if you remember is the name of the color set for the background. And we can see here the ugly safe area popping up. So we're just going to get rid of that. Dot ignore safe area, and it covers it right up. Okay, and as you can see in the app, in our final product, we've got the text kind of looking more bold and whatever. So I'm gonna streamline this and just tell you what you need. You need tracking too, because there's a little bit of spacing between each character. We're gonna do font, headline, and then we're gonna do padding because we like space. And did you guys see that, like how padding turned this blue boundary of the view, like expanded it from just the text? Like that's what I'm talking about, padding. And then so for our text score 100, we're gonna do font, title. This is once again one of the other like font sizes that I was talking about. You can find more about from the Apple developer docs. And the view modifiers for score and health are the same. So see, we've got them all bolded now. And if you've noticed, the progress view is kind of ugly because it's like not within our color scheme. Like that blue is not within our color scheme, and it's going all the way to the edges of our screen, and we don't like that. So what I'm gonna do is put some padding. And it's gonna be leading and trailing, so we don't have to worry about padding on the top and bottom. And then I'm going to make the padding 50. Woo, that looks better already. Okay, and then I said I wanted to change that color to our, like, to fit our color scheme. I'm going to use the color, tan color, in the color sets because it's the same color as our Tamagotchi. So and whoa, it worked. Okay, yeah, once again, you don't have to like memorize these view modifiers. You can just like search them up. Okay, and then for the feed button, we've got font, title 3. It's bolded. We've got space between our characters, if you can see here. So we're gonna add tracking 2. No, not 22. And then the foreground color, the color of the text, it's going to be white. Yeah, and you can see all the change that's happened to that text. Now it's white, it's a larger font, it's bold, and it's got space between its characters. Okay, and then now we want to change how the button itself looks. So we're going to add some padding to make the button bigger than just the text itself. And then we're going to do background color Right. Oh, background is once again our tam color. Look at that. It's looking nice already. And then I'm gonna do a corner radius because everything looks better rounded, in my opinion. And we're gonna do a corner radius of 15, and you can see how that has rounded the corners already. So now we're gonna do spacing and alignment. So we've talked about structs before, and you don't really need to, and I guess you don't really need to remember this, but you do, but you should know that V-stacks are structs, and spacing, which is like, you can hard code numbers to like spacers. Spacing is a variable, well, no, not a variable. It's an argument that can be passed to the stack struct. So here, adding spacing of 20 will introduce 20 pixels of spacing between every single element. Okay, so it's going to add spacing. Yeah, it's going to add 20 pixels of spacing in between every single element. And then we're going to add a spacer up here because we want everything to be in the center. And then we're going to add a spacer all the way at the bottom down here because center. Yeah, okay, that's an example of how spacers work together. Here we're going to have spacing of 30. So every single element here will have a spacing of 30 between it. And then the V stack for the score and the health, once again, I mentioned that like we put in a V stack because we want it to be aligned by its leading edge. So I'm going to pass alignment in as an argument. It's going to go dot leading, and that's going to make everything go aligned by leading edge. Okay. So it looks like we've got everything to match like what we see here. And so let's run the simulation. Go, load, load. Ah, here it is. Oh. A leading edge is, okay, so it's basically the front edge of the view. So it's like, you know how like you can align text like in a Word document to be like to the left or to the right, and then or like center. So leading is basically like aligning things by the left side. My computer is over here actually dying. It's a worthy sacrifice. Okay, let's go. Oh my gosh. Okay, there we go. So we have our app here. It took way too long to get up, but we have it here. And interestingly enough, none of the button doesn't work. The progress view doesn't change. We kind of just have a static screen. And it looks like we might need some states and bindings to make an interactive app. Now, what are states and bindings, you ask? Well, my young Padawans, come back after 10-minute break and we'll tell you.
Hey, how did you make the button change color when you click on it? Is it just automatic?
We didn't fill in when to come back, but come back in 10 minutes. That's like
Okay.
7. Okay. But the button changing color when you click on it, that's like an automatic thing. Yeah. So don't worry about it. It's like included.
Okay, welcome back everyone to part 2 of the session. So thanks to Caitlin, we built out the layout of the app. It looks really nice, looks really cute. So at this point, you're probably asking, Eugene, the name of this session is State and Bindings. We're probably going to get to State and Bindings now, right? And to that, I say, yes, we are. Finally. Okay, I lied. So we're first going to talk about a concept in Swift that's very important to the section. We've actually already seen it a couple of times already, but we kind of just hand waved it and hoped you guys didn't ask about it. But finally, we're gonna hanker down. We're gonna talk about it really quick, so you guys will be well versed in what exactly this is. So this concept is called closures, and it's really fundamental to a lot of interactive things that are going on. So on the left side, you've seen this code block before. This was something that Caitlin did earlier. I just removed out all the view modifiers so that it's a little bit easier to see. But you have a button view, which has an action parameter, and also this weird looking code block after that contains a text that ends up being on the button. What exactly are these things? There's just a bunch of curly things that are making things a mess, right? Well, in reality, these are actually called closures. So let's take a look at this first one first. So what's after action and then what's being passed into it as an input. We learned about functions a little bit before. So this is something that you're a little bit more familiar with. So for example, let's say we've defined a function on the left called print wisdom, and all it does, it prints out a couple of lines that gives you wisdom. And now something that you can do within SwiftUI is pass this print wisdom function as the action parameter in your button. And this is valid SwiftUI code. This is what it's looking for because action is expecting a function to run every time you press the button. Also, something to note is that this is print wisdom without the parentheses. That's because we want to pass in the function itself and not what it's calling, which actually returns nothing in this case because it's just printing some things out. So hopefully you guys are all in line with this. This isn't anything crazy or anything new. But what if I told you you could actually just take the content within that function and directly pass it in to the action parameter as your block of code? Well, this is starting to look a little bit more like what we started off with, and this is what a closure is. So to formalize it, closures are self-contained blocks of code that can be passed around just like any other normal variable. And it actually is basically a function, except for the fact that you don't give it a name and also some little nitty-gritty details that we get into. But this is that print wisdom function code block taken out and turned into a closure. So this is a valid closure in SwiftUI. So let's put it side by side with functions so you guys can get a handle of just how similar they are. On the left side, you have the closure syntax. And on the right side, you have the function syntax. So let's work through this one by one. Both of them have a list of parameters, which you specify within an opening and closing parentheses separated by commas. They also have a return type. So this is what you expect your function to return after you call it, and also what you expect your closure to return after this code block is run. And you can see that both the parameter and the return type are both separated by this dash closing angle bracket syntax that looks like an arrow. And finally, you have your actual body. So this is going to be run once your function is called and also when your closure is run. Now it's starting to be where we get a little bit different. In closures, because the parameter and the return type are actually all within the braces, we use a special in keyword, which is used to separate out the parameter's return type and the code itself. So that's how you kind of separate the two out. Another thing before I get into the slide is, like I mentioned before, you don't have a name for closures. So this is kind of just a piece of code that you can move around and put once. So if you're wondering why we'd use closures over functions and vice versa, you can kind of boil it down to this rule of thumb. If you expect to run this piece of code multiple times throughout your app, then it's much more convenient to use a function because you give it a name, which then you can just call over and over again later on without writing out the actual code again. It's going to be pretty redundant if you like copy paste all that code from your closure multiple times. On the other hand, if you only want to run this once in the case of the button action, because it's only tied to one singular button, then a closure is actually much more convenient. So we don't have to give a name to it. And to answer Warren's question in the chat, these are exactly what Lambda functions are in other programming languages. I just didn't want to say the name in case other people didn't know what it was, but you can find them in other languages and they'll be called Lambda functions. They'll be called anonymous functions. They all have different names, but they all basically do the same thing. So this is a real life example of a closure in action. So we're going to use the stereotypical example of adding two numbers. These are both doing the same thing. So in the closure syntax version, you have num1 and num2, and you have the return type, which because it's a sum, it'll be an int. You then put the in keyword, and then you add the two numbers. One caveat here is you may notice that we don't actually write in return. This is a special shorthand in closures that if you only have a singular line in your code, you don't need to write return explicitly. It'll just take whatever value ends up being and then return that. However, if it's multiple lines, then you still have to put return on whatever value you want to return out of the closure. And in the bottom, you can just see this function syntax that we're pretty familiar with already, doing the exact same thing. Okay, so we addressed the action parameter, which is a closure, but you may be confused why we have another curly mess after the parentheses closes. This actually is a closure too. And this is not only a closure, but it's also part of another shortcut that Swift UI and just Swift in general gives us, where if the rightmost parameter is expecting a function, you can actually leave off the parameter name, close off the parentheses, and then put that parameter as a closure after the parentheses. So on the left side, you can see the form that we've...
Could you say that again? Sorry.
I was not meaning to call Siri there, but I have no idea what I was talking about. Okay, so on the left side, you have the closures that we're expecting, and we've seen this before. And on the right side, you can see its actual form. So Siri's greedy for attention. I know I told Siri that this is me time, but some people. Okay, but on the right side, you can see the actual form where this is actually the content parameter, and we're passing in this closure as the content that's going to be displayed in the button. And yes, I am missing a closing parentheses on the right side. So this is a typo. I'll fix it in post. It should be after this brace right here. Okay, so this is explaining everything I just said. But you may have seen this, and you may have noticed that this isn't completely new, and you may think back to some other times where you've seen this sort of shortcut before. I'll give you one of them. So the VStacks, HStacks, and ZStacks that we've been working with also use this shortcut. So if you saw this sort of form on the left-hand side where you just type VStack and there's just curly braces, this is actually also using the shortcut. So it's also expecting a parameter named content, and that's what you're passing the closure into. On the bottom, I provided the full syntax that Caitlin sort of gave you a peek at in the first part of the demo. It actually also allows you to specify an alignment and a spacing. So spacing is like the amount of white space that goes between the items in the stack, and alignment is where, like which direction the stack is aligned on. These are optional. So for the most part, if you don't want to do those, you can omit those, and then you can just provide the content on the bottom, which you can make into what you see on the left-hand side. So that's kind of like what we've been dealing with. Okay, so now that you are all masters at closures, probably not, but it took me like a month to figure out what exactly was going on. We'll do a mini demo to highlight one of the pieces of code we're doing in this demo, which is implementing the feed action. So we haven't addressed this too much. Also, this is where Caitlin left off in the first part. It should be the same. Some things might be different though. This is the code that we want to concern ourselves with. So the button has an action. Right now, it's not doing anything because we just put a comment that says action. But what we want to do is when we press this feed button, we want to increase the health of the Tamagotchi to make this an actual game and not to make it like something we just stare at for fun. So I guess without further ado, let's just hop into it. So what we want to do is we want to first declare a variable that's going to keep track of health. So on the top here, let's do that. If you remember how to declare a variable, it's just var health. And I'm going to make it a double. And let's give it a default value of 50.0. Also, if you remember from last week's session, Swift does this pretty nifty thing called type inference, where if the type of this value is obvious, in this case, it's obvious it's a double because there's a decimal point, you can actually leave off this type right here and just directly put var health equals 50.0. So let's keep it that way. And what we want to do is when this button is pressed, we want it to increment the health by a set amount. We're just going to do 5 as a random number. So we're going to do health plus equals 5. So this will increment the value of health. And let's actually move this value out because we're good programmers who don't hard code values. That's a lie. I hard code stuff all the time. Ignore that error. It's yelling at us for now. I'll get to it. So let's declare this feed rate variable, which is the amount we want to add every time the button's pressed. We'll give that the value of 5.0. And then we're going to add feed rate into that here. Okay, let me give it a couple seconds because Swift is slow at yelling at you, but it yells a lot. So we have an error. Oh no, this is unexpected. So the left side of the mutating operator is immutable. Self is immutable. What the heck does that mean? I lied again. That was not unexpected. I have a slide dedicated to it. So here is the error you saw there. Left side of mutating operator isn't mutable. Self is immutable. If you're like me, or at least how I was before, you may run into a cycle of emotions. You may be throwing things around. You may be screaming. You may be undoing everything until you don't get an error, or you just might be stressed out. But if you're like me now, a completely seasoned veteran at programming, you'll know exactly what to do, which is directly copying and pasting the error into Google and just seeing what the first result is. So after this journey, I discovered something called state. The reason why it's saying self is immutable is because if you look back at this code, what we're doing is we're adding feed rate to health, and then we're trying to assign that value back into health. But in Swift, also we're in a struct. In Swift, structs are immutable in the sense that you can't change the variables once you have declared them. You can change their values, but you can't set it equal to something else, if that makes sense. But this can be avoided through something new in Swift UI, which finally is state. So let's get into the details about state. First, the motivation. Right now, we're stuck on how we need to update the Tamagotchi's health. We obviously see that normal variables won't update the UI. And if we think about it, that makes sense. Variables are just storage for values. But we need to address this, or else our Tamagotchi is just going to be perpetually in a state of limbo at 50 health, which isn't good. And uh-oh, knock, knock, who's that? It's PETA. You're under arrest for animal cruelty. We don't have to go into the ethical dilemma of whether Tamagotchi are animals or not. There's already that going on with Pokemon, but we don't want this to happen. So now let's go into the drawing board. We need a way to tell SwiftUI to monitor certain variables and allow those to change values in our structs. Not only that, we also want to be able to display the most recent value of the variable. So in our case, we want it to display the health in the form of the health bar and also in the health text. But wait a second. Has the answer been there all along? Oh my God. it's telling us to use state. So to formalize it, state are variables that are directly managed by SwiftUI. They look almost exactly the same as normal variables with a small detail change we'll get into. But once you declare a state variable, these variables will be a special case regarded by SwiftUI. And whenever their values are changed, the view will be updated to display their most recent value. You can consider state variables as our source of truth. So you have one singular point of data, which is your state variable. And this is the value that you're going to be passing around to other views so that all of them will be kept in sync. And if you want to learn more about state, I left the documentation to the Apple developer docs on the bottom. One way to think of state is through an analogy with cars. So when you think about a car, it has a ton of internal state going on at the same time. For example, it has a specific fuel level. It has a speed you're currently going at, et cetera, et cetera. This information isn't directly useful to us because they're just numbers and we're in the driver's seat and we can't really see that going on. So it would be really useful to have a dashboard that's right in front of you that displays everything visually to you. It'll show you what your fuel is currently at. It'll show you what speed you're currently going and all that fun stuff. It is very, very important that that dashboard is displaying the most current value and most updated value of your internal state. You can imagine if the fuel level on the dashboard says you're at 80%, but you're actually at 0.1%, or if your speedometer says you're at 30 miles per hour, or you're going at 100 miles per hour, that's not good. You might get arrested, and we're not liable for that. So use your state variables because they make sure that things change and things update the way they're supposed to. So finally, we'll get into the syntax of state, which is almost similar to the way you declare and assign normal variables. So on the right half here, you can see var is awake equals false. This is how we declare a Boolean variable called is awake, and we set it to false. But now we have the addition of the special annotation, which is at state. So this formally marks a variable as a state variable. You may have also noticed we add the private keyword right after state. This is just convention. We won't go too much into detail about what it's doing. At a high level, what it's doing is it's saying that this variable can only be accessed by anything within the struct, but nothing outside the struct. Okay, so now that we have our newfound knowledge, let's go back and add the state into our health. Let's also display and update the health. So let's pass it into our health bar and let's pass it into our text. And the last bullet point is a lot more morbid than I remembered, but let's make the Tamagotchi feel pain. Let's make it slowly lose health over time. We'll get into the third bullet point after the first two. Okay, so the error is still there. Swift is still angry at me, or I should say Xcode is still angry at me, but it won't be angry for too much longer. All we have to do is mark this as a state variable using at state and private. And now this should be a normal state variable. And would you look at that? The error is gone. So this should be good. In this current state, it's not going to update anything because if you look at the current state, whoops, the current, I'll just say state. This is hard-coded. This is also hard-coded, the parameter passing into the progress view. We want those to be the updated values of our health variable so that we see an actual representation of our internal state. You can imagine this is like if our dashboard in our car was just a printout paper of what a dashboard looks like. It's like not actually updating anything. So let's change that. Let's address the health first. We're going to use string interpolation, which if you remember from last session, is a way to directly inject your variables in here to display their value in strings. So this will be health. And we're going to go down to progress view as well. We're going to take out the hard-coded value, and we're going to instead pass health. Okay, so once we do that, and we build and run our code. Okay, cool. So good news, it is working. Bad news, it looks ugly because of all these decimal points. So we'll go back to that later. But we should see that our health bar is also messed up. Oh, yeah. So there's a out of bounds error because progress view wants its values from 0 to 1. So we're at 50 right now. That's just what I'm more comfortable with to think of health from 0 to 100. So we can just fix that by dividing this by 100. And let's address the other problem at the same time. We're going to use something called typecasting, which is how you convert the type of a variable from one thing to another. So if we want to take out the decimal points, all we have to do is typecast this from a double to an int. So we'll just surround this with int and parentheses, and this will do the job. So let's run the code again. You have sharp eyes, Warren. You got there before I saw it. Okay, so now it looks good. The decimal's gone. Boo, decimals. And the health is 50, so our value is reflecting that. Once we've hit feed, this should update. So let me click it once, and nice. We can see that the state variable is updating the views, and SwiftUI is handling things as we expect. So we'll hit that continuously, and it's at 100. So that's good. Let me hit this one more time, and then you'll see another error, which is the out of bounds value, because right now we're allowing it to go above 100. So that's an easy fix. All we have to do is slightly fine tune this so that instead of just letting it add stuff indefinitely, we're going to cap it at 100. So we'll take the minimum of health plus feed rate and 100. So these are two values that we're passing into minimum. This is just saying if this sum here exceeds 100, make it 100. Otherwise, you can keep doing the sum. So if we run that, oh, I just realized I'm leaking my DMs. I'll quit that in a second. Okay, so if we feed, now we're good to go because we have capped it at 100 and we're keeping it in bounds. Okay, goodbye DMs. Cool, so Aditya has a question. Could we have passed a mutating function to action? So if you're saying if we pass a function that's set as mutating, and instead of a closure, we make it go into, or we pass in that function itself?
Yeah.
I think it should work. Wait, sorry if I'm taking a detour. So let's say mutating. Also, let's just call this do action. So, okay. So if we do that, not yelling at me yet, and then we pass that in as our function. Yeah, okay. So I think Alex is right. I don't think that they let you do that. Nice, that's good to know. I actually didn't know that either. Okay, cool. Are there any questions up to anything I've said up to this point? I think the rest of them have been answered. Okay, cool. So we've addressed the first two bullet points. Let's get to the third one, which if you recall is to make the Tamagotchi feel pain, because I guess I'm just sadistic like that. But it will make our game more fun. So to accomplish this, we're going to make it so that every second, our Tamagotchi is going to lose a set amount of health. So to do that, we're going to use something that's built into SwiftUI called timers. To start a timer, you use this first statement. So we're just declaring a state variable called timer. And then we're using this built-in class called timer. And then what we're doing here is we're just publishing a timer that runs every 1 second. And these are other parameters. I won't go too much into detail about what they mean. Main is like the main thread, that making sure this runs on the main thread. I'll stop there. You can look into it later, or you can ask me offline. But this is how you start it. So this is auto connect. That's how you start the timer. Okay, next one is how you quote unquote restart a timer. There isn't really a direct way to do this in Swift, so you can just accomplish the same thing by reinitializing it, by just setting it equal to the exact same thing we've done above. And last but not least, if you want a view to update every time the timer ticks, you're going to add this special view modifier onto your view called onReceive. You want to pass in your timer variable, and look at that, we're using closures. So every time you receive a timer tick, you're going to run this closure, and you're going to run the code inside here. And you can see like it's expecting a parameter in our closure, but because we don't really care about the value, you can just put an underscore there because that's the special character that just means we don't care. Okay, so let's do that. I forgot which direction my code was. Okay, so let us first declare that timer. And also, so one thing to note is that we're making it a state variable because of the fact that we need to reinitialize it. Otherwise, Swift is going to yell at us again for immutable stuff. So it's timer.publish. That's not how you spell publish. That's still not how you spell publish. Okay, every 1 second, we can ignore the tolerance parameter since that's not required. On main in common. And we can get rid of the rest of this. So now we have published a timer, and to start it, we can just do .autoconnect. I'm going to copy this code because we're going to need it, or I guess we don't need it, but that'll be an exercise for you guys later on to restart the timer with the restart button. But for now, we're just going to start it, and we're going to have it so that at every tick, we want to decrease the health by a set amount. So we're going to declare a variable called dying rate. Sorry, that's still really morbid. We're going to set it to 20. So every second, it's going to lose 20 health. And we're going to now add a closure using onReceive to, it really could just be any of these views, but to keep things consistent, I'm going to put it on the health text view. So we're going to do .onReceive, and we'll pass in timer. And here you can see the perform parameter expects a function, but we can just use what we learned so far to put the closure after it instead. And we'll put the underscore as the parameter because we don't care about the parameter. All we want to do is decrement health by 20. And if you have keen eyes, you might be thinking of this thing below where we had to cap it at 100. We have the same problem here where we have to make sure it doesn't go under 0. So that way that's going to look like is taking the maximum of health minus dying rate and 0. So if health minus dying rate dips below 0, you'll just keep 0. Okay, so this should be good. So if I run the code, I should slowly die. Let me close these other things too. Okay, nice, we're dying. Oh, that was recorded. Okay, so cool, decrement stuff every second, and we reached 0 health. But this isn't complete if you think about it, because yes, we're at 0, but we could still keep playing if we wanted to. It would make more sense if once we hit 0, the game is over and we stopped playing. So that's going to be our next job, which brings me to the next use case of state, sort of extending from that and defining different actions based on state. But before that, actually, I wanted to give you guys a little bit of an exercise. If you noticed our code, we still haven't addressed that score is hard-coded too. But we really don't want that to happen. What we want is every second, we want to add a specific amount to the score because we've survived for that long. So the longer we survive, the higher our score is going to be. Hopefully neurons are firing in your head about how to accomplish this, but we're going to send out a poll, which is actually going to be you writing the code for me for this next section. So let me share that. And I'll give you guys a couple minutes for that. Okay, in the interest of time, I'm just going to end it. Hopefully you had a chance to answer. Let me end the poll and share results. So first question, which of the following is the correct way to declare and assign a state variable called score? And it looks like all of you got the correct one, which is good and bad. I was looking forward to explaining the rest of them. But yes, that's how you declare a variable called score. If you see the second option and that looks familiar, the use state one, that is actually syntax for state in React Native, which is not the same as Swift UI, but just a little fun fact. Cool, so let's take that and we'll put that in our code. So state, private variable, score, int equals 0. And again, because there's no decimal point, it can sort of infer that 0 is an integer, so we can actually take this out. Cool, so we have the first part. Number 2, now we want to update the score by 100 whenever the timer ticks. What should the closure we pass to onReceive look like? Hint, onReceive expects a function that has one parameter. So the hint is very important because I see that one of you put the second option. I hope the options are in the same order, but the second option is just the one with no parameters. We actually do need a parameter because if we don't, Swift will, or Xcode will yell at us because the closure that onReceive is expecting, it has a parameter. But we don't really care about it for our purposes, so we can just do an underscore in and then the incrementing our score. So score plus equals 100, which the majority of you got. Okay, so let's add that now. Let's go to our score text. And let's add an onReceive to it. So it'll receive the timer, and we're going to pass in the closure from the correct answer. Oh, keyword isn't working. Okay, nice. That gave me flashbacks to last session. Okay, so we have the timer, and we want to increment the score by 100. So, oh, forgot the parameter. Wait, let me let the error sink in. Cool. Oh, that's not the error I was expecting. Anyways, sometimes the errors aren't related really to what's actually going on. So hopefully it'll go away after this. Yeah, sorry, sometimes it's just confusing. Okay, so we're good for that. And before I forget, let's stop hard coding the score value and let's string interpolate
Uh-oh. Let me pause the recording.
Okay, for those of you on the recording, sorry about that. I was just about to build this and run this to see if our code works. Okay, so we're dying, yay. Okay, add the health, and the score is now incrementing every 100 seconds. So that's exactly what we want. Nice. Okay, cool. So up next is what I sort of alluded to previously. It's nice to display the state, but if that was all that was possible using state, then that would be kind of underwhelming. The real power of state comes when you define different behavior based on the different states available to you, or the different state values. So, I saw the chat. We're dying, yay. So if we have a Boolean variable, the one we defined before, with is awake is false and true, depending on which value this state variable takes on, we can do different actions. So for example, if is awake is false, aka we're not awake, we want to not do work and we want our energy to recharge. On the other hand, if is awake is true, so we are awake, ideally we want to do work and we'll lose energy over time. But this isn't the case. Usually I just go on TikTok for half of the day, but I rest my case. So if we think about our app right now, it's useful to define whether the game is running or the game isn't running. This might not be clear right now, but let me just walk through this and I'll implement it. But let's say we have a Boolean variable called game is running. If that's set to true, we want to keep adding score because we're still in the game. We want to start losing health because that's part of the game. And we also want the button to feed the Tamagotchi to be enabled so we can keep adding health to it. On the other hand, if we set the game is running to false, we want to stop adding score because that's the score that you get. We want to stop losing health because the game is over. And finally, we want to disable the feed action so that we can't keep adding more health once the game is over. So that's really cool, I would say. Another use case, which we don't really show here, you can define different views to show depending on different state variables. You can imagine like an is VIP Boolean variable. So if you're a VIP of the app, you want to display extra special things, or you want to make things gold. I don't know how VIP status works, but if you're a normal user, you don't show any of that stuff. So that's another use case for why state variables are good. So I digress. Let's go back into our demo. We want to fix the problem that when health reaches 0, we want to stop the game. And we also want to disable the feed button so that it can't keep adding anymore. So let's go back. Let's define the game is running variable. And let's first set it to true because when the game starts, we just want the game to be automatically running. If you weren't lazy like me, maybe you'd implement a start button, but for the purposes of this demo, we won't do that. Also, because I'm lazy again, and also in the interest of time, it would also be a better programming practice to just put all of these in a game object because they're all like keeping track of different attributes of a game. But we'll keep it like this for now. So game is running is true. And what we want is to update our pieces of code to keep that in mind. So if game is running, and this is our if conditions that we learned last session, if the game is currently running, we want to keep incrementing the score by 100. You can note that in this case, we don't really need an else because if the game is not running, we just don't do anything with score, which is basically the same thing as adding 0 to score. Next part we want to tackle is this section, which is a little bit more involved. So we are currently just dying indefinitely, but we only want to die if the game is running. So let's do that same check. If game is running, then we want to do this losing health functionality. Otherwise, we don't want to keep decrementing the health. However, we want to be able to flip the state of health once we reach 0, because Once we reach 0, the game is over. So game is running should be set to false. So let's do an additional check for what the value of health is. So if health has hit 0, we want to flip the state of game is running to false. And the last section, I believe that needs this is here. If game is running, then we will add health. Oh. Okay. So that should be good once we run this. Let's just die. Too many quotable things today. Okay, so once we die, you can see different things. So you may have noticed once I click the button here, we're not adding any more health. The score isn't incrementing anymore. And it's not as obvious, but we're also not losing any more health once we hit 0. So this is exactly as we wanted. I'm just going to be a little bit more fancy. It isn't directly clear to the user that this button is disabled because it looks the exact same. But let's add a special view modifier that we haven't covered yet. It's called disabled. And disabled is expecting a Boolean. So if this Boolean is true, then this button will be disabled. Otherwise, it is not disabled. So you can keep doing it. So you can kind of see that there's opposite logic. So if the game is running, we want it to be not disabled. And if it's not running, then we want it to be disabled. So we just add the special operator, the exclamation point, to flip the value of the variable. So once we add that, and we hit 0. Once we hit feed, you can see that it's not giving us any indication that this button is being pressed anymore. So that's good. There's another view modifier. I won't go too much into detail about it, but it's called opacity. And this is sort of like how strong the colors are. It goes from 0 to 1. And if we wanted to, we can set it so that if game is running, it has a lower value, like 0.5 or something. Otherwise, we keep it at 1. Again, in the interest of time, I won't put that here, but it's in the complete demo if you wanted to take a look at that yourself. Okay, any questions I can answer? All right, cool. Okay, let's take a little bit of an aside, because if we take a look at our code, well, I guess this isn't too bad, but you can imagine that if we keep adding functionality into our view, it's just going to keep getting bigger and bigger. And there was this piece of advice that I learned from a movie that I take to heart, and I think you guys should as well, but this will be on the slides for infinite wisdom in the future. So in general, a good programming practice is to make our code modular. If you don't know what modular means, it just means that each file should be responsible for a single task and nothing else. So right now our content view is doing a lot of different things, like it's keeping track of the health bar, it's implementing the feed button. That really isn't modular. And we should really improve that by creating new files and moving out code so that each thing does a singular thing. So on the bottom half of the slide, I've outlined a couple of things that you can improve. One that I'll be showing you guys is this new custom view we're going to declare called feed button, which solely handles the feeding of the Tamagotchi and those related actions. Another one that you can do is called stats view. And that one, for example, can display the current score, the current health, and it'll also have the health bar. So once we extract the view out and put it into its own file, you have this chunk piece of code that you were working with before with our button. It's okay if you can't really see it. The purpose is just so you see that's a lot of code. But once we move it into another file called feedbutton.swift, all we have to do in content view is call it just like we would any view. And all we have to do is pass in any relevant parameters that that view needs. For those of you with sharp eyes, you may have noticed that there's a $sign here. I'm not obsessed with money. We'll get into it in a bit. It's related to bindings. Spoiler alert. Oh, we don't have an error yet, my bad. Okay, so let's extract the view. So let's create a new file for this purpose. So if we right click here and we select new file, we'll get this this pop-up, sorry. We're gonna go down here and select Swift UI view in iOS in user interface. Because we are trying to declare a custom view, we're gonna call it a feed button just to be consistent with what the slide said we're gonna do. And it gives us this custom code. This is the same code you started off with in content view. It's just the default code that you need to create a feed button and also display that in the preview. But we're gonna go back to content view and we're gonna copy all the code. That's not the curly brace. We're gonna copy all this code and we're gonna paste it into the body of this new custom view. And the indentation's a little bit weird. I'm gonna show a shortcut, but if you select all using Command A, and then you press Control I, it'll automatically re-indent everything for you. You don't have to remember that. It's also one Google away. Okay, so we're getting errors again, which isn't fun. Let's see what it looks like. Oh, cannot find game is running scope. Okay, so let's declare these variables first off so that they have values to refer to. This is a Boolean. We also have our health, which I anticipate will be another error. That's a double. And finally, we have our feed rate, which is also a double. Okay, so we have errors. This error is a little bit different. It's saying that we're missing arguments because we've defined these new parameters on the top. So when we create the struct, we actually have to come up with values for them. I'm just going to pass in some dummy values, 0.0, so it stops screaming at me, 5.0. I'm also aggressive with it saying that it's screaming at me. It's more politely reminding me that there's an error, but I'm going to keep saying screaming. Cool, it's our old friend again. Self is immutable. The trauma. Okay, so let's treat this error now. So, oh no, we have an error again. This would be a lot more surprising if I accidentally didn't put the slide here. But now we're running into the same immutable error as before. If you think about how we addressed the error in the first place, which is adding state, that won't exactly work this time because what that's going to do is it's going to declare a completely separate state variable. But we want to somehow associate the variable before, the state variable before, with this view so that when one of the variables updates, the other one does, and vice versa. Because if we look back to our new view, we don't want this to be a new game is running variable or a new health variable or a new feed rate variable. We want it to be linked to the previous ones in our content view. If these pictures are giving you any hint, another synonym for associate is bind. So we want to bind these variables. Okay, whatever. Next, we're talking about bindings now. So this is just an add-on to state, and it's a way to have two-way communication between the first state variable that stores data, which we can consider is our source of truth, as well as a view that changes data. So now you can think of that as the content view with our original state variables, game is running, health, and this view that changes data is our feed button in a separate file. So with bindings, not only can you change the state variable from the content view, but you can now also change the original property from this other view. So in our case, it's the feed button view. So again, I provided the documentation link here if you want to learn more. A little bit of terminology first before I start talking about this a little bit more. We have a notion of a parent view and a child view. You can see the relation here. Our parent view, which we've seen so far is our content view, will include our state variable as a property, and parent views contain other views, which are called child views. And conversely, child views are contained within the parent, and they will change data contained in the parent view. So in our case, that's like the game is running within the child view, also the health variable, and all that sort of stuff. So let's walk through an example of bindings. On the bottom right side, you can see the state relationship with another child view that we've already seen, but we're going to focus on the bottom left, which is a binding now. So let's say that we have a property called numCars. I honestly don't know why I'm still on this cars thing, but you have both of these variables and they're bound to each other. So once we update the parent view's numCars to be 2, we expect the child view's numCars to also become 2. This isn't anything new. This was also doable with state variables. But what is new is that if you update the numCars within the child view, that will also update the numCars within the parent view. So that isn't doable without bindings. So here's the syntax for bindings. You can kind of anticipate that because we have a parent view and a child view, there's going to be a little bit more things you have to do this linking. So first thing, to bind a state variable from your parent view to a property within the child view, you're going to add the $ in front of the state variable. So what this is doing is it's binding the value property in the child view to the state variable in the parent view. So now you get this sort of this binding, this association between these variables so that they both update in step with each other. The second piece of syntax is within the child view, you need to declare a binding. So this is very similar to what we've seen with state. You just add the @binding annotation to the variable declaration. Okay, so if I had more time, I would have gone in depth with a demo about this special built-in view in SwiftUI called slider, but I'll just explain it at a high level. I've left the documentation there so you can play around with this yourself, but you have the slider. I think most of you are familiar with how a slider works. You just hold on to the little circle there and you can move it around. And slider views require bindings, which if you think about it, does make sense. So if you have a state variable in content view that's keeping track of the value, we can just call it slider value. We need that to update in step with what the user is doing. So when the user is moving around this little circle, we need that state variable to also update its value to whatever that value currently is within the slider. That wasn't doable before with just a state variable, but now we're able to update this value from within the child view using bindings. Are there any questions so far? Okay, then the last thing I'll do is I'm going to finish off the demo by fixing this error and adding that binding between the feed button and the content view. This is pretty simple. All you have to do is change all of these variables to binding. So we'll add @binding and we'll add @binding here. We don't have to make feed rate a binding because we don't really manipulate it from within this file. So I'm just going to keep it the way it is. This is going to start yelling at me because it'll say you can't pass in a Boolean. You need to pass a binding to a Boolean. So we can, for this purpose, since we don't really care about these values, we can use a shortcut to turn this into a binding, which is .constant, and then wrapping this around the value we want to pass in. That converts it into a binding. We're going to do the same thing for health here. Okay, and once we do that, we are good. So all the errors are gone. Let's do that second part of the binding syntax, which is linking our state variable to be passed into our feed button. So we see that there isn't really an error because we actually didn't call feed button at all yet. But once we call that, we'll have our parameters auto-completed for us. Game is running is expecting a binding of a Boolean. So if we just pass in game is running, it's going to give us an error because this is just a normal Boolean variable. But if I add that $, and then I'll do the same thing for health, and I'll add feed rate, there shouldn't be any problems with this because we've successfully linked the two properties together. So once I run this, oh, whoops, clicked it twice. All right, so looks like everything's good to go. So we didn't really add new functionality to this. We were just good programmers by extracting out the feed button. And it looks like all the functionalities are the same. So if I let this die, you can't feed anymore. So everything's good. Cool. So that's just where we're going to leave off for the demo today. We have a couple exercises for you. You may have noticed in our screenshots of the app, there's another restart button here. There's also the opacity issue. You also may notice that this face that the Tamagotchi is making is not pleasant. It's not as happy as the one before. So some exercises for you. First one is to implement the restart button. Make it look like that with the drop shadow, the borders, and all that stuff, and add the functionality behind it. So it should set the game to be running again. So basically what any restart button does, you should restart the game. You should set the health back to its default value of 50, and then you should set score back to 0. The second thing is to create a custom image view for your Tamagotchi so that it can handle different emotions. So if the health is greater than 50, for example, you want to set it to be happy. If health is 0, you want to set it to dead. And last, you want to set the image to sad tam. All of these names I'm referring to are assets that are directly available in the demo starter code that I've given to all of you. So that's all there for you. All you have to do is do the actual implementation. And the solutions are written in the README, so you can check what you're doing is correct. And also all the code is there as well. Okay, that is it for this workshop. So thank you all so much for coming. Hopefully you learned something new today. Please fill out the feedback form. We always look at them and we always make sure that we're improving based on our feedback. Next week, we're talking about advanced views. So someone earlier mentioned scrolling. That's something interesting that you can do that we haven't covered yet. There's also multiple screens that you can work with. We've only been working with one screen so far. So for all that, stay tuned for next Wednesday, 6 p.m. But with that being said, thank you so much.